Okay, the last problem we're going to work on here today is we want to be able to compare two functions, but we have one function graphically, the other function we have algebraically. So here's a graph that represents the height of a baseball in feet, h in feet, as a function of time, t, in seconds, after it was hit by player A. So this graph represents player A. Function g is defined by this function, g of t equals the quantity negative 16t minus 1 times the quantity t minus 4, and it also represents the height in feet of a baseball. Uh, Height in feet in t seconds after it was hit by player B. So this uh, function algebraically is player B. So without graphing the function, we want to answer the following questions and explain or show how you know. So the first question is, which player's baseball stayed in flight longer? Uh, so to answer that, this is player B here. To answer that, let's look at player A and let's determine how long was player A's baseball in the air. Okay, so if I look at this graph, I see that player A has some initial height here. It looks, to be about 5 feet, 4 feet maybe. The ball is hit. It goes up into the air and then it lands just after 5 seconds. So, looking at this point, it looks like it's about 5.1 seconds. So, I'm just going to make note of that. About 5.1 seconds. Okay, so player A's ball lands at about 5.1 seconds. Now, if we want to figure out when did player B, when did that ball hit the ground, what we need to do is we need to take this function, right? And we want to know when is the height equal to 0. So we'll take this entire function here and we're going to set it equal to 0. So negative 16t minus 1 times t minus 4, and have that set equal to 0. Now remember, if we're looking for the x-intercepts here, what we did before was we have two things multiplied to equal 0. So we can take each of these, set them equal to 0, and solve. So let's take this first thing, this negative 16t minus 1, set it equal to 0. If we solve this, this gives us an idea of when the ball was on the ground for the first time. So we do this by adding 1 to both sides, and I get negative 16t is equal to 0 plus 1 is 1. Then I solve this by dividing both sides by negative 16. And I get t is equal to negative 1/16. Now, we know that that doesn't make any sense, right? That's one of those extraneous solutions because we don't consider negative time. So now we need to look at the other part here. We have t minus 4. We can set that equal to 0 and solve this by adding 4 to both sides. And I get t is equal to 4. So that does make sense. So player B's ball hits the ground at 4 seconds. Player B hits ground at 4 seconds. So which player's baseball stayed in flight longer? I would say player A, because it hit the ground at about 5.1 seconds. So player A stays in flight longer. And that's about 5.1 seconds. Okay. Now we want to know which player's baseball reached a greater maximum height. So let's first look at player A here on the graph, and the maximum height for, oh, where'd it go? The maximum height for player A looks to be about, oh boy. So the maximum height for player A looks to be right about here, which is, I would say, about 105 feet. It looks like. So we're wondering, what's the maximum height for player B? Well, we can figure that out is by finding how do we figure out what the y value for the vertex is algebraically. So we have these two x-intercepts. We have negative 1/16, and we can change that to decimal by dividing it out. It's negative 0.0625 comma 0, and my other x-intercept here is 4, 0. Remember, to find the vertex, we got to average the two for the x value of the vertex. So I'm going to take the negative 0.0625, I'm going to add 4 and divide by 2. So that negative 0.0625, add 4, and then divide that by 2. And that tells me at 1.97 seconds, that will be how long it takes to get to the maximum height. Now, to figure out what that maximum height is, I need to evaluate the function for 1.97, for an x value of 1.97. And my initial function was negative 16 times the 1.97 minus 1, and then multiply that by 1.97 minus 4. Okay, so I'm going to evaluate this. Negative 16 times 1.97, subtract 1. Negative 16 times 1.97, and then subtract 1, and I get negative 32.52. And I'm going to multiply that by 1.97 minus 4. 97 minus 4 is equal to negative 2.03. I multiply these two together. 1.97 equals, I'm going to multiply those two values. So negative 32.52 times negative 2.03, and I get 66.02, which is definitely lower than player A. Okay, so I would say player A has greater maximum height. Now, how can we find the height at which each baseball was hit? Well, again, player A, we just kind of guess it was hit at about 4 feet. We don't know. It might be 5, it might be 3, it might be 6, but it's around 4 feet. For player B, remember, to find the height, what we need to do is remember when we FOIL this out, if we multiply these two constant values, -1 times -4, that gives us, when we use the box method, that gives us that constant at the end. So player A and B both at 4 feet. Okay, so that's it for this one. This one's a little bit tougher. You have to do quite a bit of algebra to answer this question, but I know you guys can handle that. So good job, and you're going to be able to now move on to doing the practice.